So let's talk about the importance of caching. This can be within Rock or with any system. A lot of you are creating extensions to Rock or plugins into Rock or writing just even separate code that has nothing to do with Rock. And caching has to be an architectural component in these systems. If not, you're missing out on performance, and you might be putting scalability issues into other systems that you are reading against. So what is caching? Caching is a mechanism to store frequently accessed data in fast temporary storage to prevent having to retrieve it from the slower original data source. This process improves performance and availability of an application and increases the scale. So it's really important that you consider what data that you're reading at all times within your application. As you write it, it's easy to not have empathy for what the computer is going through. And it's often the case that you might be creating issues within your own application, or you might be causing other issues with the source systems that you're reading from. We see this quite a bit with Rock when people write against the API. They just basically feel like, well, we could just make as many calls as we need to and everything should just be fine. And then their application doesn't perform, which they put back onto Rock. Well, why is that? Why Rock can't scale? And it's like, well, actually what you're doing is creating API abuse. You shouldn't read the same value from Rock thousands of times in an hour. If that's happening, you should be caching that value in your local application. No system can take a denial of service attack, which is really sometimes what these applications turn into when they don't have their own cache. It's really just a denial of service attack that was written by another developer. And so we're constantly have to be understanding the impact that we're having within the systems. And we call this having empathy for the computer. Now, when we look at time within a computer, it's very, very different than when we compare time to a human being. The scales of time are just vastly different. And sometimes it's so vastly different, it's really hard to understand and comprehend the speed differences and understanding what a computer is having to do. So what we're going to do here is we're going to convert computer time and human time, and we're going to take it away out of the time side and we're going to convert it into distances, just so that we can better understand what's happening within the computer and give it context into what we understand as humans. Okay, so for the next few minutes, we're going to be converting time into distances to compare and contrast how fast things are. Okay, so within a computer, the CPU has a clock, and the clock is ticking, and it ticks very, 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 very fast. So we're going to apply a distance to that of 4 inches. So every clock tick, the time it takes to tick the clock, consider that, for comparison, 4 inches. Now, CPUs have their own internal caches right on the chip, and they have several of them. The first one is called the level 1 cache, and to read from that cache takes the amount of time it takes comparatively is like 12 inches. So it takes 3 clock ticks to read from the level 1 cache. They also have a level 2 cache, which is a little bit slower, and it's 34 inches in terms of comparison. They have a level 3 cache, which is even slower. It's 155 inches, so that's a lot more. And then we have the main memory. So this is the memory that if you build your own computer, it's the one that you kind of click into the motherboard. Now that one, whoa, that's a lot slower, right? So we actually went off the page. It's so much slower. So that's 100 feet. So consider that. Like every time you even go into read from memory, the poor CPU is like, what? I'm gonna have to wait around for a while because this is I've got to go 100 feet to get that thing. But as you'll see, that's actually still very fast. So let's renormalize our chart here. Okay, so we're going to kind of simplify this again. One CPU's clock tick is 4 inches. Random access memory is 100 feet. Okay, we got a new chart. Let's look at some other things. Whoops. When we go to the SSD, that's the hard drive, a fast hard drive. Wow, SSDs are super fast. But in comparison to reading out of memory, super slow. So now we've just gone 9.4 miles That's a huge difference. Now let's re-normalize our chart again, because that, we already blew off that chart. So at the top, CPU 4 ticks, random access memory 100 feet, SSD 9.4 miles. Let's look at some other real world things. Now remember I said SSDs, solid state drives, are very fast. The older style rotating hard drives are way slow compared to that. That's like going from New York to Baltimore, 109 miles. So now you know why everybody wants an SSD, and pretty much everybody has one now. Some of the cheaper laptops still have rotating disks, but that's why no one wants them. They're so much slower. But, we're working with Rock, we're working with these systems. We're really about databases, right? And so let's do a simple database read. So this would be like, get person where ID equals 12. It's that simple. We're using an index. It's super fast, except it's like driving from Detroit to New York. That's almost 500 miles. So now you're starting to get the idea of like why we want something in cache. Cache lives in RAM, that memory. In most cases, it's in RAM. And so that's like going 100 feet versus going 500 miles. If someone told you, hey, I need to pick up a loaf of bread, would you rather walk 500 feet to get it, or would you rather drive 500 miles? I mean, pretty obvious. We like things in cache. Now that's a simple database read. Let's just keep going a little bit. Let's look at maybe a more complex database read. And so that's like going from New York to Oslo, 4,000 miles. And that's a database read where you're making multiple joins and doing some where clauses. Probably some of those criteria in the where clause might be on indexes and maybe a couple aren't. So big difference. And on these complex database reads, this is another really stellar example of when you want to use the cache. So just for fun, let's think about a computer reboot. When the computer reboots, we complain. Think about the computer. The computer from its time, it's like going all the way from Earth to Mars and back. So the computer's like going, oh, you're going to reboot me? Oh, gee, see you in a long time. And so, what might take 3 minutes or 4 minutes to us is the computer's taking years in its time. So that's why you really want to understand it and use cache to its fullest. And so you might ask the question, well, if all this is so slow, why don't we just put everything in L1 cache on the CPU? And it really comes down to money. That cache that's on that chip, the reason why it's so small is it costs so much money, and we simply can't afford to use that for everything. But RAM, memory, is not that expensive. It's way more expensive than the solid state drive, so we can't put like terabytes of RAM into the computer in a price effective way. But we can buy more RAM in terms of gigabytes to put more things in cache, perhaps. So we do have to have this balancing act of where we store stuff and how much we spend. Also, RAM is what they call volatile. So like when the computer shuts off, everything in there is lost. So we do need to write that out to a place that when the computer does reboot or has to be reboot, that we don't lose everything. And that's why we have the hard drive, and that's why we have SQL databases to make sure that we store things in ways that they're safe and quickly to retrieve. So that's just a little bit of an overview about cache and why it's so important. And you need to be thinking about this, even if you're not a developer. If you're a Lava script writer, you want to make sure that you're effectively using cache, because that Lava is creating a lot of database calls. It's a lot of trips to Detroit to get your data for one page. And so using cache, you put it 100 feet away and things are much faster and allows your server to scale.